Hey guys, what's going on? This is Swerve for you, and I'm coming to you with another Fallout 76 video. Now, today, I'm not going to be playing the game, but we're going to be talking about nuke codes and how to decrypt them and the whole process behind that. Now, this is not going to be a tutorial for how to join the Enclave or, how to become a general to get into the Enclave bunker. This video is going to assume that you've already done that and you're just interested in getting information on how to decrypt the key pieces that you're finding and what the words in the bunker mean and all that fun stuff. So before we get started, we are going to talk about that. But before we get started, I've made an Android app. I've written an Android app that's going to allow you to decode the codes a lot more quickly, a lot easier. You don't actually need to know everything behind it. You can just put in the information and it will do it for you. The first half of this video is going to be about the app, how to download it and use it. The second half of the video is going to be about how to actually decrypt the codes. So if you want to skip to that part, there's going to be a link in the top of the description. You can click to do that. But before you do, I recommend at least giving the app a look, because the app can do things that a human just can't do. Like search 50,000 words in a few seconds, or run the cipher on all 50,000 possible keywords, in 20 or 30 seconds. So, even if you want to learn how the process is done, I recommend at least just give the app a download. I mean, it's free. I'm not trying to sell you anything. Give it a shot. I think you'll find it a useful tool in your toolbox. So, the first thing we need to do, of course, is to download the app. And it's on the Play Store. Now, I'm recording this on my computer because I can't easily capture video from my phone. You'll just do this on your phone. So just search for Fallout 76 Nuke code, and then you'll see it. Sometimes its position varies. Here, it's right here at the top. You'll see it's got my name, Fallout 76 Nuke Code Decryptor. So just click on that and download it. Of course, I've already got it installed, but that's how you get the app. And then I'm going to use an emulator to run the app. So once you get the app downloaded, just start it up. So for the interface, I went for functional over flashy, so it doesn't have a super slick interface. But the important thing is it works, and it works very well. So the first thing to notice is there are three buttons at the top for Alpha, Bravo, and Charlie. What this does is this lets you keep track of all your key pieces separately. Your the codes that you find on the officers, you can put those in as the letters are revealed in the Enclave bunker. You can put those in. You don't need to save it. It automatically remembers as soon as you enter the letter, and it will remember it during the week. Now, the new codes reset at Tuesday, midnight on Tuesday, Greenwich Mountain Time, which works out to be about 7 p.m. Eastern Standard Time on Monday. So that's when the codes reset. The app will not reset the codes while you're in it, actually looking at it, but if that time passes, the next time you restart the app, it will erase everything and give you a notification, and you'll start with a blank slate, because the new codes do expire every week. So, and I realize that there are websites that you can go to get the same information once the codes are posted, but if you're like me, if you're a do-it-yourself person, or you just want to get the codes as early as possible, and maybe they haven't been posted yet, this app will allow you to do that. So, the first thing that you're going to need are the key code pieces, which you can farm. You can get missions in the Enclave bunker to get those as soon as they reset, so that's something you can do immediately. And then you will also need the key phrase from the Enclave bunker. As those letters are revealed, you just put them in, and it will guess it at as soon as possible. Now, if you have the key codes put in already, the key pieces from the officers rather, it will be able to narrow the field and predict this a little bit faster. So what we're going to do is we're going to just use a sample data set that I came up with. These are sample key pieces, and then these are the sample letters. So if we just put those in, to enter the letters, you just click on one of the positions. And I want to show you something real quick. To know which position the letters go in, this is a sample of what the the display in the bunker looks like. You can see here it uses a flip panel display. Each position, up here represents the letter down here, and because they're all the same width, we can look and determine which position the letters are in based on these letters up here. So, we know there's one space here because there's one letter above it. We know there's two spaces here because, there's two letters above it. Even if there's like a letter way over here and none of these are filled in, it's very easy to count. Let's say there's a letter under O. We just count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We know that's in the 12th position. So that's how that works. All right. So here we can see, based on the position under the I and the S, that E and B, of course, are in the second and the fourth position. It's easy to see here, but sometimes when the letters are further out, it can be a little more difficult. So just click the second position, and we put in E. Now, if you make a mistake, you can just click back on the letter and re-enter it, or hit space to clear it if you put in the wrong one. But we'll do E, and then you can either click on this fourth one, or you can just hit space. You can see this. The one that's highlighted is a little bit bolder. You hit space to skip to the next one, and then put in B. Now, we only have two letters, and unfortunately, there's about 50, well, the dictionary I use, there's over 50,000 words in it. There's just not enough information yet to decode the keyword, or so it would seem. We haven't put in the key code pieces yet, and so let's go ahead and do that. So this is a lot easier to do on your phone, trust me. But we'll put these in D1. You can see, again, there's a highlight, shows you which position you're in. It does not matter what order that you put these in, only that the letter is above the number. The position of these is, of course, critical. The correct letter is above the correct number. It doesn't matter the order. All right, so put in C3, H4, G5, A6, P7, and B8. Now, after we put these in, you'll see that it filled in the word completely, and when it guesses the keyword, the background will go green, and it was able to decrypt the Nuke code. And the reason that happened is because when you enter these key pieces, there's only, out of those 50,000 words, what it does is it runs the cipher on all the potential words. And for some of those, it's able to detect, we'll go into the exact process here in a few minutes, but it's able to detect that some of those aren't valid. So by entering the key pieces, you cut down on the possible number of keywords. And in this case, it allowed us to guess the keyword with just 2 letters. That's the advantage you get with the app. You just can't do that as a human. By the time you ran all those potential ciphers, the week would be over and your codes would be expired. So that's the advantage that the app gives you. So to show you kind of how that works, I'm going to just click over to Bravo here. As you can see, it keeps track of your results separately. So we're going to enter those same key letters in. Now you can enter the key, or the key codes in. You can enter the key codes without putting in any letters from the bunker. However, just a warning, and you'll see when you do that, the search process takes, I haven't timed it, but it's 30 seconds to a minute, just because it's basically running cipher on every possible keyword. So it's a very long process, but I want to show you why we're able to narrow the field. All right, B8. So it's searching, and you'll see 52,593. That's the total number of keywords I have in the dictionary here. Now, just to note, I don't work for Bethesda, so I don't have the dictionary that they used. The dictionary in here is a combination of 3 free online dictionaries that I put together because the first one I had didn't have all the words. So I kept combining dictionaries until I was satisfied. There may be a few missing words. I highly doubt it. And there may be some words in there that Bethesda doesn't use, but I'd rather err on the side of caution. I don't know how many words are in their dictionary, but there's a lot of really crazy words in there, things that you just wouldn't think of. And that's another advantage that the app gives you, is that it will, it can search through all those words in a minute here, where, it would take you, it's basically running the cipher on 50,000 words. You'd have to get out pen and paper, do that. It would take you a very, very long time. So when it gets through, once you have the key code pieces put in, it will show you a list of every possible Nuke code and tell you how many there are. And that's what we're going to look at here to see, how much we've narrowed the field down. We know we initially start with 52,000 possibilities. So once it narrows that down, then when we put our letters in, we're picking from a much smaller group of words. So that's what lets us guess it, in a quicker amount of time. Now, if you have a search, if you have a few letters from the bunker put in at the top, it's actually going to cut that down tremendously. It's not going to take that long. So here you can see out of all those words, we've cut it down based on these, just the key pieces with no letters entered. We've cut it down to 577 possible keywords, and these are the possible codes. So now, when we go to enter these, so we put in the E, and it will search again because it has all the key pieces. Once you have those in, it will search, every time. And then just with the E, again, we've cut it down to 55 possible codes. So it's possible, now when I put in the next letter here, the B, of course, it's going to guess it. But let's say that we just picked another one. I don't know, it may guess it from this one too. No, it didn't. So see, now there are 3 possible matches. So even though we haven't fully guessed it, I mean, we only have 2 letters here. If you had a few key cards to spare, you could just guess and, potentially, get the right one. You got a 1 out of 3 chance. So you can get, if you're looking to get it just as early as possible and verify which one it is, then go for it. But once we put in this letter here, it will narrow it down to the one choice, and then it will get the entire keyword. So, you can gamble if you want a little bit with some key cards if you get it narrow enough, or just be patient and wait till you get all the letters you need. So that's really all there is to using the app. You really just put the letters in, and it won't let you the keywords and also the key codes here. You cannot duplicate letters between them, and it won't let you put duplicate letters in. So if you attempt to do that, it's not going to let you, and it'll just fail. So it's pretty foolproof. Like I said, there's not much you can do to mess it up. So that's it. Give it a shot. If you feel like downloading it, try it out, and if you like it, rate it. Let me know what you think. If you encounter a bug, my email address is on the Google Play page. Just let me know, and I'll get on fixing it. So now we're going to talk about the actual decryption process, what the app's actually doing. And the first thing I want to talk about are the keywords. So I'm sure you're probably aware there's a lot more than 50,000 words in the English language. How do we cut it down to 50,000 words? Well, all the keywords are isograms. And what an isogram is an isogram is a word that has no repeating letters. So a word like colander, that has 2 L's, got to throw that one out. Replace has 2 E's, throw that one out too. A word like deobfuscating, all the letters are unique. So that is a valid word, and that is one of our keywords, as you saw. So the keyword has a range of 6 to 15 letters. Based on personal experience, I've seen, these are actual keywords that I've seen. After checking, there are no 16-letter isograms, no valid ones. So 15 is definitely the cutoff. 6, I mean, we can go less than 6 letters, but I highly doubt that that's, that there's any less than that. And that's what, kind of the general consensus on the internet is as well. So first thing I want to look at here is, and just realize this is just common sense really, but since we have a requirement of the words can't have repeating letters, then the longer, when we use longer words, there's, a much higher chance that we're going to have a repeating letter in a longer word. So the number of valid words, falls off dramatically as you get to, higher number letter counts. So what that lets us do, like, here's the total. As you can see, these are actual counts from the dictionaries that I use. So a word like, uncopyrightable, yeah, there are only 2 valid 15-letter words. Uncopyrightable is one, and whatever that word is the other one. So the point I'm trying to make here is that letters that are later on in the sequence give us more information than letters that are at the first of the words. So this is a sample of basically the 3 words we were just looking at. What you might see in the missile silo when you go there. So each one of these, even though they all have 3 letters revealed, Bravo gives us much more information than Charlie because Bravo has a letter in the 13th position. So what that means is that we can ignore all the words from 6 to 12 letters. Now, if you take a look here, just the first 3 sets of words, if we look at just 6, 7, and 8, add those up, that's 40,000 words right there. 40 out of 50,000. That's 80% of the words are in the 6, 7, and 8. So if we have a letter in the 9th position, we can ignore 80% of these words. So that's very helpful to us. Here, you can see there is a letter in the 9th position at Missile Silo Alpha, and we only have 12,000 words we have to search through. Here, because of the letter in the 13th position, we only have 84 words we have to search through. But since there are no letters past the 6th letter here, we have to search all 52,000 words. So what I'm trying to say is that it's going, how much of, or how quickly you can guess the word is going to depend on the position of the letters revealed. It is going to be random. Sometimes, it's going to take a while to guess it. If the wrong letters are revealed, sometimes you can get it pretty quickly. And sometimes, which I'm going to demonstrate that as well, even if you have all the letters, all the keyword letters, and all the key code pieces, sometimes there are multiple valid codes once you know everything, and you just have to guess. So that's kind of how this works out. So we're going to look at the cipher and see how this actually works. So once you have, the first thing you're going to need is you're going to need the actual keyword from the Enclave bunker, and of course we're guessing that. So, in this case it's going to be de-obfuscating. So what we do is we write that word out. Now, then we construct basically the rest of the alphabet in order, and these are the letters that were not used in this word. So if you look at the letters in this word, A is used, B, C, D, E, F, G. H is the first letter that isn't used, so we put it there. I is used, and we've got J, K, L, M, and so on and so forth until we construct the rest of the alphabet. So we do that, we put it in order, and then we tack it right on the end, and then we take the normal alphabet and we put them together. We'll call the first one the cipher alphabet, and the second one, of course, just the normal alphabet. So this is why it's important that the words are isograms or there's no repeating letters. Because if I had, say, 2 L's in here, well, I'm only going to be able to take 1 L out of the actual alphabet. So this word or this alphabet is going to be longer than the other one, and that just won't work. They have to be the same width. So that's the reason for that requirement. Now, we're going to look here at a sample set of key codes. Here we've got H1, F2, Q3, N4, so on and so forth. So the way this works out is that these numbers that you get when you get all the key pieces, these are actually just the numbers in the Nuke code. It's an 8-digit code. But you don't know what order they're in. And the letters are what tell you what order to put them in. But if you look at them, they're just a scrambled bunch of nonsense. That's because we have to run them through the cipher. So what we do is, now that we have our cipher alphabet, to get the correct letter for this, we look at H, and we find H in this alphabet here. And we go immediately down below it and say, okay, so the actual letter for that is N. Same thing for F. We look at F, and the actual letter is E. So I've taken the liberty of putting all these together, and we're going to place that right under here for a quicker reference. So now once we have decoded this, we're actually done with the original letters. We don't need those anymore. So what we've made here, you can see these letters don't really make a lot of sense either, but they're actually an anagram. An anagram being a scrambled group of letters. So it will make a word. Sometimes it will make more than one valid word, and that's the case where you get multiple codes for the same, you have to just guess. But in this case, it only makes one real word, and that word is enthralls. Now, normally enthrall has 2 L's. However, there's an alternate form of it that only has 1. So this is the kind of weird stuff you get into with the dictionaries, and that's why it's better to just let the app do this. So what happens is, as you unscramble this word, these letters are locked to these numbers. So when I move E to the first position, I also move 2 to the first position. When I move N to the second position, I move the 1 over. The T actually stays in the same place. The H comes from position 7, so when we move it over, we move it. As you can see, so we move those, we unscramble those letters, and we move the numbers with them, and we end up finally, after all that, with our Nuke code. So I want to, just to show you the process for doing this, I'm going to punch this in. We'll go to Charlie here, because I'm pretty sure, yes, I used a different set of letters there. So we'll put this in, and actually, rather than do that, hold on, we're going to do it like this. I'm going to show you another set of potential key codes here. We'll get rid of these because I've already tested these. All right, so here's another potential set of key codes, and then that will give us this set of letters here. The problem is that those 8 letters will unscramble into 2 valid codes. So we don't know which one it is, and there's absolutely no way to tell without guessing. So that doesn't happen very often, but it can happen, and I will put it in here just to show you. Oh, okay, guess that rather quickly. And then we will just put these letters in just to show you. E1, F2, Q, oops, that was W. Q3, N4, P5, M6, C7, and D8. Alright, and after it processes, you will see that we have 2 valid codes. And we have all the information, we have the correct keyword, we have all the key pieces, and we're stuck with 2 codes. That's just unfortunate, and it will always, the app will always show you, all the valid codes. So, you just have to, at this point, you just have to, flip a coin, and hopefully you don't waste your key card. But if you do, once you find the correct code, obviously then that's going to be valid for the rest of the week. So guys, that's it. That's really all there is to it. I hope this video helped you out. If it did, give it a like and consider subscribing. If you want to download the app, like I say, please rate it. Let me know what you think. Any ideas for improvements, please feel free to hit me up with those in the comments or, however you'd like to do it. So until next time, peace.